Ever wonder how your smart home detects a gas leak before it becomes a disaster? Or how hospitals spot life-threatening changes in a patient's vitals seconds after they occur? It all starts with anomaly detection, the science of identifying the rare, the unexpected, the outliers in a world drowning in data. But here's the catch. As our systems grow more complex, traditional methods are struggling to keep up. Let's break down why that's happening, and how a breakthrough called DAD is rewriting the rules. Imagine you're at a party. Most people are chatting, dancing, and having a good time. But one person is standing alone in the corner, acting strangely. That's an anomaly, a data point that doesn't fit the pattern. Now scale that up to thousands of sensors in a factory, or millions of transactions in a bank. Each of these systems generates multivariate time series, data that changes over time and involves multiple variables. Detecting anomalies in this chaos. It's like trying to find a single thread in a tangled web. Traditional methods like k-nearest neighbors or isolation forests have been used for years. But they're slow, memory-heavy, and often miss subtle patterns. Think of them as detectives who rely on old case files, good for past crimes, but not great at predicting new ones. For example, if a factory's temperature, pressure, and vibration sensors all look normal individually, but together they signal a problem, these methods might miss it. Plus, they process data in chunks, which creates delays. In a world where seconds matter, that's a big deal. Enter DAD, Decorrelation-Based Anomaly Detection. This is the next-gen solution, and it's a game changer. Here's the trick. Instead of storing all past data, DAD learns on the fly. It's like a detective who doesn't look up old records, but pays attention to how people's behavior changes in real time. DAD focuses on decorrelation, how variables interact and diverge from their usual patterns. If a sensor's data suddenly doesn't fit with the others, DAD flags it instantly. What makes DAD stand out? First, it's single pass. It processes each data point once, making it super fast. Second, it's robust to high dimensions. It handles dozens, even hundreds of variables without breaking a sweat. Traditional methods crumble under this pressure, but DAD thrives. And third, it's practical. The researchers designed it to adapt automatically, so it works seamlessly in real-world scenarios, from smart grids to medical monitoring. Let's dive into the technical heart of DAD. Traditional anomaly detection often relies on statistical thresholds or fixed rules. But DAD takes a different approach. It models the expected relationships between variables. For example, in a hospital setting, a patient's heart rate and oxygen levels typically move in tandem. If one spikes while the other drops, DAD recognizes this as a deviation from the norm. It doesn't just look for outliers. It analyzes how variables should behave and flags when their interactions break down. To test DAD's effectiveness, researchers pitted it against 20-plus existing methods using real-world datasets. Take the hepatitis dataset, 80 patient records, 19 metrics, and 13 hidden outliers. Traditional tools. They missed some. DAD, it caught them all. But here's the twist. DAD didn't just find outliers, it understood why. By tracking how variables should behave, it flagged anomalies that others overlooked. In another test, the L9 dataset challenged models with subtle shifts in correlations, how variables connected, without changing average values. Imagine a classroom where students, individual grades stay the same, but their group projects become wildly unpredictable. DAD spotted that shift, while other methods didn't. H8, a trickier dataset, hid complex patterns in data relationships, like a puzzle with pieces that only make sense when viewed together. DAD cracked it, but others couldn't. So why does DAD dominate? It's not just about finding outliers, it's about adapting. Traditional tools rely on fixed rules, like a map that never updates. DAD, though, learns as it goes, adjusting to new patterns in real time. It's like a GPS that updates itself while you drive, not just following a preset route. The results? DAD didn't just perform well, it dominated. On some datasets, it achieved perfect scores, outpacing methods that had been the gold standard. And here's the best part. The researchers made their code open source. That means you can try it yourself, tinker with it, and see how it works. What's the real-world impact? Imagine monitoring sensors in a power grid, spotting early signs of a blackout. Or analyzing medical data to catch diseases before symptoms appear. DAD's ability to adapt to complex, changing data makes it a game-changer for fields from cybersecurity to climate science. So the next time you see a smart device or a monitoring system, remember, behind the scenes, innovations like DAD are working tirelessly to keep things running smoothly. Thanks for watching, stay curious, and let's keep exploring the science shaping our world.